Hi, I just wanted to make a quick video about this current prototype that I'm working on. What this is I like to think of it as a rigging engine, so something in the vein of Bifrost, or maybe more closer to a bit closer to Control Rig in Unreal. But as kind of a standalone application that can be embedded into any other application, so Maya, I don't know, Max, Blender, Unreal, a custom engine, anything. At least that's the goal. I don't know if this is going to be that realistic, but yeah. So the way it works is I've got this node graph on the side, and as I create, like I just created an output node, and as I created this node, you can see that on the right, I've got some actual source code that was generated, and this output doesn't really show much yet, but if I add an attribute, it's going to be a bit more interesting. So this source code, and so excuse me, I can't actually zoom in there. So if it's a bit tiny, I'm sorry. But the source code that's generated contains three main things. It has this definition for the main function, which is this whole graph, like the content of the whole graph right here will be inside of this main function. This main function does one thing: it returns an instance of this main out struct, which we defined just above. This struct is basically a specification of all the attributes we have on our output node. So as I add another one or like two other attributes, we have more output fields in the struct, and then we have more values fed in the instantiation of the struct. This language right here is a language that I actually created myself, both the syntax and the interpreter for it. Right now, nothing is really happening. We return an instance of this struct with 000, and at the end of the actual bit of code, we call the main function that is defined just here. So this output window just pretty much prints the output of the main function. So if we have just a struct that has three fields, all of them are 0, not really interesting, but we can actually just like change these values. This gets reflected dynamically here, and again, we don't process these values at all, so they are just printed out as is right here. So before things get a bit too more complex, I'll just actually restart this because I can't actually delete nodes yet. So let's start over, create a new output node with just one single output attribute. So we've got one field here, we just pass one value to this, and then just get, well, the struct with one field in there. One thing that I could do is just add an add node, and as nothing was really changed as I added the node to the graph, because that node isn't connected to the output, so you can maybe consider that to exist but being commented out or something, but for all intents and purposes, this node just exists visually yet, at this point, sorry, but doesn't really exist in the code yet. But as soon as I connect it, it becomes part of the graph, and we've got this line that's added right here. What it is a function call to the add function with those two values passed as the first and second argument, and then the result of this gets assigned to the add variable, which is the name of the node here. So the add function is the type of this node. The add name of the variable is the name of the node. I can't rename nodes yet, but if I were able to, this would change to the name of the node, but this would just stay add. So I can change these values. It passed these two values here. 34 plus 19 is 53. So we can see that we've added the values together, bound them to the add variable, and then passed the add variable to this struct instance, which is printed out here. I could do something a bit more complex, so let's add a multiply node. Well, actually, let's do the opposite. Multiply the result by, like, I don't know, 2. One thing I forgot to mention, these widgets, I haven't implemented a way to hide them once a connection is made, so just ignore them. Once a connection exists, these like don't really do anything. But yeah, so I'm taking this, which is 34 plus 19, and then I'm piping that into a multiply node, just multiplying this by 2. What I get is this multiply function call that takes the result of the add node, so the result of the variable that we've just defined above, and we multiply them by 2. And then finally output the result of the multiply function inside of this struct, which means we've got 106. If I were to pump that up, that number would grow quickly just because this is a multiplication. I could, I don't know, reset that, sorry, and then just connect those two. So now I'm feeding add to itself, so essentially squaring the value. Yeah, that's kind of all that's supported right now. Actually, no, I forgot one pretty important thing. The input node. This node defines the kind of arguments of your function. So right now we've got this empty parentheses. But if I were to add an input here, we can see that we have an input 0 argument to our function. Just like because this main call is only exists because I want to like visualize the output. I don't have any way to set the value of that input argument, so that number right here is just a random number between 0 and 100. This number is going to change every single time I update anything in the graph. So if I were to even update something that's completely unrelated, this number just gets updated every time. But I could use that number and like add it to itself and then multiply it by itself. So 17 plus 17 times, I guess 17, or like that, and that result squared, I guess would be that value. But yeah, this is kind of where it stops right now. I haven't blended anything else at this point. My goal was really to figure out that pipeline from going from a node graph to an actual, like some actual source code, and then actually interpreting that source code. I could, I don't know, add more attributes if I wanted to pipe that value as the output directly. So this 26 now gets passed straight to the return value. So we've got that 26 here. Yeah, I don't think I could really do much more. I guess the next step is, well, first of all, supporting more data types, because floats are nice, but you can't. You need a bit more than that to actually build rigs. So I would want to support vectors, matrices, quaternions, and like operations that actually work with those. I probably won't really go far on that end with this implementation, because I forgot if I actually said this, but this is all written in Python at the moment. Definitely not the language I would want to use for the actual final product, just because it would be way too slow. I haven't really landed on which language I want to use yet, but yeah, I'll see down the line. One thing that I think I will implement in the Python prototype is grouping nodes together. because this is an actual like important feature that should really be in any node graph thing. So if I were to group these nodes together, this would just create an extra function. So let my function equals fn. This would take one, or either one or two, depending on how you see it, but let's go with one argument. So arg0, and then the body of the function would be these two functions that we had here. So extracting these two variables into their own function. I didn't name the argument the same way, so let me just rename it, pass these in right here, and then these would have only one return value, so I could just return multiply here. So the variable multiply is returned here. My language doesn't have like a return keyword, so the last expression in the function is whatever is returned. I'm not really attached to the syntax that I have at the moment, so this is just how it currently is. If my this function was outputting more than one single value, I would need to also, just like I did for the main function, create a struct and then assign multiple values within that struct and then return that whole struct. I think this is the way I would actually go about it. But what I forgot to do is then call that function that I just defined. So let my var equals my function. It takes in a single argument, which would be this value, and then I could use my var here. What I've just written here is actual valid code. The only thing that's not implemented is, well, grouping nodes together in the graph and then showing or generating the code, the text that matches that grouped logic. But this is actual valid code here, and if I had the signals connected properly, we would see I guess the same values, because I didn't really change anything. I only extracted those two lines into their own function. But that code would still work, yeah. So yeah, I think this is the main thing that I would want to support in that prototype before actually building this in a proper language that would be actually able to evaluate this pretty fast. Now, the thing that I don't really know, like I might still keep that UI and all of the front end in Python or something else, and only implement the interpreter or like the virtual machine behind it in a faster language, something like C, C++, Rust, Zig, something like that. Ideally something that would be easy to integrate in any existing application. So C, maybe C++, Zig also sounds like an interesting choice. But yeah, I've not made my decision on that at all yet. So I'll see when I get there. I think that's pretty much it. I can't think of anything else to show. Not that there's much to show, but hopefully you found that interesting as an interesting like proof of concept. I'll try and post more videos if I make more progress on that or when I do. So I'll maybe see you there.